The pre-calculus video for the semester exam review for first semester. Number one, the point A is given by -3, 2, and B by -5, 4. And we are supposed to find the length of the segment. So we're going to be using the distance formula, the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So we just plug in the coordinates. -5 minus -3 squared plus 4 minus 2 squared. And -5 minus -3 is going to be -2. And 4 minus 2 is 2. And that's going to be 4 plus 4, which is the square root of 8, which simplifies to 2 square root 2. So that is your answer to number 1. Find the slope of the line for number 2. Find the slope of the line joining the points -6, 3 and 2, 7. So slope formula is y2 minus y1 over x2 minus x1. So for the points we have, that's going to be 7 minus 3 over 2 minus -6, which is 4 over 8, which is 1/2. Find an equation of the line through 0, -2, and perpendicular to the line 2x plus y equals 7. So if we solve this for y, we get -2x plus 7. And so the slope of this line, sorry, needed to move my paper up. The slope of this line is -2, so the slope of the line perpendicular to it is positive 1/2. And they gave us the y-intercept. And it says in the directions up above, write the equations of the lines in slope-intercept form. So y equals the slope, which is 1/2 x minus 2. That's all we need to do for that one. F of x is a linear function, and f of -1 equals 4, and f of 5 equals 8. We want to find an equation for f of x in terms of x. So basically we want to write the equation of that line. And this is just function notation. This means the point -1, 4. And this means the point 5, 8. And so to find the slope first, we take 8 minus 4 over 5 minus -1. You get 4 over 6, which is 2/3. And then we plug that into y equals 2/3 x plus b. And now we pick one of the points. So I'm going to pick 8 equals 2/3 times 5. So 8 equals 10/3 plus b. And then subtract 10/3 from both sides. 8 is 24/3. So 24/3 minus 10/3 would be 14/3. That would be b. But instead of writing y equals, we're going to write f of x equals, because it wanted us to find the function f. We're in function notation. And so it equals the slope, which is 2/3 x plus b, which is 14/3. Number 5. A is 4, -1, and B is 8, 3. And we want to find the coordinates of the midpoint. So the midpoint formula, that's a big M, is x1 plus x2 over 2. It's like finding the average, add them up and divide by 2. y1 plus y2 over 2. So for this one, we would have 4 plus 8 over 2 and -1 plus 3 over 2. And that's going to give us 12 over 2 is 6, and 2 over 2 is 1. 6. Find the value of h if the line joining -2h and 413 is parallel to the line 3x minus 2y equals 1. And so parallel lines have the same slope. So I need to find the slope of this line. -2y equals -3x plus 1. So y is 3/2 x minus 1/2. So the slope here is 3/2. The slope of the line parallel to it is 3/2. So now I just come up here and I take h minus 13 over -2 minus 4, and that's going to equal 3 over 2. -2 minus 4 is -6, and then I cross multiply times -3 is, or times 3, sorry, is -18. And over here I'll have 2 times the quantity h minus 13, which is 2h minus 26 equals -18. We'll add 26 to both sides, and we get 2h equals 8. Then divide both sides by 2, and h is 4. Number 7, we're supposed to simplify 4 plus 3i times the quantity 2 minus I. So let's see. That's going to be 8. And then minus 4i plus 6i minus 3i squared. Well, minus 3i squared becomes plus 3. And -4i plus 6i is plus 2i. And then I combine like terms, the 8 and the 3. My answer is 11 plus 2i. Remember that a complex number has to be written in the form a plus bi. If I write this as 2i plus 11, technically it's incorrect. Number 8, 5 plus I over 5 minus I. So to clear the imaginary number in the denominator, we multiply top and bottom by its conjugate, which happens to match the numerator, which makes that multiplication a little bit easier. So in the top, we're going to have 25 plus 5i plus 5i minus I squared. And in the denominator, we're going to have 5 plus 5i minus 5i minus I squared. And I'm just trying to show all my work so you know where I'm coming from. So in the numerator, that's going to be 25 plus 1, which is 26 plus 10i. And in the denominator, we're going to have 5 plus 1, which is 6. Now, since everything is divisible by 2, we can reduce. So 13 plus 5i all over 3 would be our final answer. Simplified all the way. Okay. Number 9. 7 plus 3i, 20 squared. And you need to remember that that's going to be 7 plus 3i times 7 plus 3i, okay? So 49 plus 21i plus 21i plus 9i squared. So that's going to be 49 minus 9. 49 minus 9 is 40. And then plus 21i plus 21i, I didn't write that down right. 21i plus 21i is 42i. For 10, we have I to the 71st power. So the closest multiple of 4 is I to the 68th times I cubed, and I cubed is minus I. So I to the 71st is minus I. Don't know why I went to 12. I guess wishful thinking. I'm almost done, but number 11. We're supposed to solve these equations. So we have x to the 4th minus 15x squared, and then I'm going to go ahead and set it equal to 0 because that's what we need to do. And then this is of the quadratic form, so x squared, I can factor it, x squared, or I could use a factor puzzle. I know some of you, and that's good. It's a good way to organize your. So x to the 4th would be here, negative 16, and negative 15x squared. So x to the 4th is x squared times x squared, the factors of 16 that are going to make 15, obviously 16 and 1, and so this is 16x squared and 1x squared, and I need the 16 to be negative in order for that to work. And so here's my negative 16 over here. So this is x squared minus 16 times the quantity x squared plus 1 equals 0. We set each factor equal to 0. X squared minus 16 equals 0. X squared plus 1 equals 0. So x squared equals 16. Take the square root of both sides. We get plus or minus 4. Subtract 1, we get x squared equals negative 1. Take the square root of both sides. The square root of negative 1 would be plus or minus I. So it says to give all roots real and imaginary. There you go. Number 12. The square root of 3n plus 10 equals n plus 1. So with radical equations, we isolate the radical, already done, and then we square both sides. So 3n plus 10 equals, remember this is going to be n plus 1 times n plus 1. So that's going to be n squared plus 2n plus 1. And we'll set that equal to 0. So n squared minus n, and then minus 9. And don't tell me that doesn't factor. I told you not to tell me. Did I do that right? It doesn't factor. I'm pretty sure that the one I put on the exam does factor. It just, if it doesn't factor, it makes it a mess, because we have to use a quadratic formula, and then we have to determine which answer is not the correct answer, because usually, obviously, it's going to turn up two answers. One of them's not going to work, and it's usually the negative one that doesn't work. So I'm going to abandon this, and hopefully we'll find one in class that will work better. I apologize. I don't know how I could have changed it. N squared minus n. So something with like a 6 would work. So if I made this 7, if I would have made that 3n plus 10, 3n plus 7. Let's see if I can get this to work now. 3n plus 7, and then I subtract 7 from both sides. I get minus 6, right? We go to our factor puzzle. N squared minus 6 minus n. The factors of 6 that'll make 1 would be 3 and 2. And so we need the 3 to be negative, this one to be negative. So our factors are the quantity n minus 3 times the quantity n plus 2. So n minus 3 equals 0, n plus 2 equals 0. So n is 3 or n is negative 2. We plug in 3, we get 9 plus 7 is 16, square root of 16 is 4, and over here we get 3 plus 1 is 4. We plug in negative 2, we get negative 6 plus 7 is 1, and the square root of 1 is 1, and over here we get negative 2 plus 1 is negative 1. 1 does not equal negative 1, so we throw this one out, and that's our answer. Okay. Number 13, 4a minus 7b, why don't I just use x's and y's, equals 13, and 2a minus 7b equals 3. So this is set up for elimination. If this were a positive 7 over here, the b's would drop out. And so to make that a positive 7, I just multiply everything in this equation by negative 1. So we get negative 2a plus 7b equals negative 3. And so we add these together now. 2a, that's gone. 13 plus negative 3 is 10. A is 5. Then we can plug that into either equation. It doesn't matter. I'm going to plug it into this original. So I'll get 10 minus 7b equals 3. Subtract 10. Negative 7b equals negative 7. B is 1. So these lines intersect at the point 5, 1. All right, moving right on. We are 18 minutes in, and we are ready for number 14, which is x to the 4th minus 5x squared plus 2x plus 8 equals 0. Okay, so this is one where we're going to have to use synthetic division. Factoring by grouping won't work. 1 negative or 1 0 because there's no cubic term. Or wait a minute, I wrote it down wrong. It's a cubic term, it's an x cubed, not an x to the 4th. My bad. So 3, 2, 1, 0, everything's there. So 1, negative 5, 2, and 8. And then rational roots theorem, the factors are plus or minus 1, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So it's these over these. So since this is just plus or minus 1, essentially it's all of these, right? I'm going to try 2. So bring down the 1. Not there. Bring down the 1. Multiply, add. That's going to be negative 6, negative 4. Oh, wow. Got lucky. First one works. So x equals 2. And then this leaves me with x squared minus 3x minus 4. Look how good this turns out. This factors. You can go to your factor puzzle if you wish. This would be x squared minus 4, 3x, x and x. It's going to be 4 and 1. And I need the 4 negative. So factors into x minus 4 times the quantity x plus 1. So x minus 4 equals 0, x equals 4, x plus 1 equals 0, x equals negative 1. So this is the cubic. We should expect 3 roots, and there they are, 2, 4, and negative 1. Number 15. Sketch the parabola. Y equals 2x squared plus x minus 15. Find the intercepts, axis of symmetry, vertex, domain, and range. So this isn't in graphing form, it's in standard form. So find the vertex, we take the opposite of b over 2a. So I don't know what I wrote that for. The x-coordinate of the vertex is negative 1/4. Then we plug that in. So 2 times negative 1/4 squared plus negative 1/4 minus 15. So negative 1/4 squared is 1/16 times 2 is 1/8. And then that's minus 1/4 and then minus 15. My common denominator is 8. So if you don't believe me, you can get your calculators out and do this. 1/8 minus 2/8 minus 120. 15 times 8. 0 carry, yep, 120. So then 1 minus 3 is negative, no, I'm sorry, that's a 2. 1 minus 2 is negative 1. Minus 120 over 8 would be negative 121 over 8. That's lovely. Wow. Not taking it easy on you, am I? So the vertex is negative 1/4, negative 121 over 8, which is negative 15 and 1/8. Okay. Then the axis of symmetry, x equals negative 1/4. The domain is all real numbers. The range is y is, this opens up, so greater than or equal to negative 121 over 8. Somebody should really check my math on this because I did that totally in my head and I may have gotten it wrong. So let's see, domain, range, intercepts. The y-intercept is 0, negative 15, and then the x-intercept, I don't know if this thing factors. No. It looks like it might. 2x squared, negative 15, x, 2x and x, 3 here, 5 here, gives me 6x and 5x. I need the 5 negative. So it does factor to, there's not even enough room on this paper for all this. It factors to 2x minus 5 times the quantity x plus 3. So the x-intercepts are 5/2 and negative 3. So 5/2, 0, and negative 3, 0. Intercepts, vertex, domain, range, axis of symmetry, and then the graph. And the graph is, negative 1/4, which, let's see if that's 1. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the vertex would be at negative 1/4. So over here, and then negative 15 and 1/8, which would be here. And then negative 3 would be, and 5/2, which is 2.5, and yeah, so it's some. Oops, I missed. It's something like that. So hopefully I was kinder to you on the actual test. Number 16. Here we go. Find the quotient remainder. Ooh, this is a good one. Find a quotient remainder when x to the fourth minus 2x cubed plus 5x plus 2 is divided by x plus 1. So we'll use synthetic division there. The squared term is missing, so I'm going to put 1, -2, 0, 5, 2, and I'm dividing by -1. So bring down the 1, multiply, add, multiply, add, multiply, add. Oh, wow. Remainder 0. Wonder if I did that on purpose. So the quotient is, this was x to the fourth, so x cubed minus 3x squared plus 3x plus 2, and the remainder is 0. 17. Sketch the graph of y equals x cubed plus 5x squared plus 6x. And then state all the intercepts. One intercept will be 0, 0. All right, that's the y-intercept. And then we can take out a greatest common factor of x and be left with x squared plus 5x plus 6. And then that factors to x plus 3 times the quantity x plus 2. So the zeros, the x-intercepts, the x-intercepts are 0, 0, -3, 0, and -2, 0. So we draw our coordinate system, and 1, 2, 3, 1, 2, 3, 0, -3, -2. And it's positive out front, and it's a cubic, so I start down here, up through, up, down, up. There it is. Number 18. This is a good one too. We have 6x cubed minus 5x minus 2. And we're supposed to find the sum and product of the roots. Well, the sum is going to be 0. Because remember that the sum of the roots is the next highest degreed term, its coefficient, over the coefficient of the highest degreed term. And since the next highest degreed term, the squared term, is missing, its coefficient is 0. And 0 over 6 is 0. The product of the terms for an odd degreed function is the opposite of the constant over the leading coefficient, which is 6. So the product of the terms is 1/3. That is it. 19. Let's see. 1 minus 2i is a root of x cubed plus x plus 10 equals 0. Find the other two roots. Well, the other root would be 1 plus 2i. And then 1, 0, 1, 10. I'm going to try -5. 1, -5, -5, 25. No, that's not going to work. I'm going to try -2. -2. 1, -2, -2, 4, 5, negative 10, there she is, 0. So the roots are 1 minus 2i, 1 plus 2i, that's the complex conjugates theorem. And then using synthetic division and the rational root theorem, negative 2 was the other root. Remember that the factors of 10 would be plus or minus 1, plus or minus 2, plus or minus 5, and those would be over the coefficient of my leading term here, plus or minus 1. So I chose negative 5 first. It didn't work, so I went to negative 2. I knew it had to be one of the larger numbers because I needed a 10 out here at the end. Okay, so we got it. All right, the big dog, number 20. F of x equals opposite of the quantity x plus 2 squared minus 4. And the domain is x is greater than or equal to negative 2. Okay, basically that's what that says, translated off of the paper. So this is the inverse problem that we are working on. So first what I do is I like to graph them. So for the function, I'm going to plug in, I'm going to start with negative 2 because that's the beginning of my domain, and then the x's are greater than or equal to that. So I'm going to go to negative 1, 0, 1. We'll see how high we get there. Okay. And so when I plug in negative 2, I get 0 in here, so it's going to be negative 4. When I plug in negative 1, I'm going to get 1 squared is 1. Negative 1 minus 4 is negative 5. When I plug in 0, I'm going to get 4 in here, but that's going to make it negative, so it's going to be negative 8. When I plug in positive 1, I'm going to get 3 squared is 9. Negative 9 minus 4 is negative 13. So numbers are getting kind of large there. Okay, so this is my function f of x. All right. My inverse, f minus 1 of x, that's how we write the inverse. The ordered pairs will be, remember for an inverse, xy gets mapped into yx. So I flip them around. Negative 4, negative 2, negative 5, negative 1, negative 8, 0, negative 13, 1. And I don't know that I'll graph that last one, but we'll see. So I make my graph. I make my y-axis a little bit smaller up top there. And then 1, 2, 3, 4, 5, 6, 7. Oh boy. That's not going to work. Let me try that again. And it would be better if I was on graph paper. Maybe I should wait and do this. So again, 1, 2, 3, 4. There's negative 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 2, 3, 4, 5. 2, 3, 4, 5. Okay. Negative 2, negative 4. Right here. This is the original function. Negative 1, negative 5. 0, negative 8. And 1, negative 13. 11, 12, 13. This is the right side of this parabola that opens down. Okay? Trying to make everything so you can see it on the page. Now I'm going to graph the other one. So -4, -2, -5, -1, 0, -8, or no, -8, 0, sorry. So that would be here. And -13, 11, 12, 13, 1. And so there is that other, and remember this is a reflection over this line, y equals x. Okay, it's a reflection over that line, y equals x. Not too bad. Okay, so then the range of the original function, I don't know if we're supposed to find that, but I'm going to put it here just in case. The range of the original function is from this point down. So y is less than or equal to -4. The reason I write it down like that is because now for my inverse function, okay, and I don't have the rule for that yet, the domain is what I have for the range up here. So the domain is x is less than or equal to -4. And the range is what I have for the domain up here. X is greater than or equal to -2. And that's why I take the time to write that up there. And the reason that it switches like that is because xy, if you remember, gets mapped into yx. So the domain here becomes the range over here, etc. Okay. Now to find the rule. And the rule then, we take the original function and we change the notation from function notation to y equals, okay? And then we interchange the x and the y. So this becomes x, this becomes y. And then we solve that for y. Now, if you multiply this out, and we talked about this in class, if you multiply this out, you're going to be doomed. You won't be able to solve it. Okay, you have to leave it in the form it's in to get y by itself. So add 4 to both sides. Oh, shoot. Okay, get rid of that negative. So multiply everything over here by a negative. Minus x minus 4 equals y plus 2 quantity squared. Take the square root of both sides. So plus or minus the square root of x minus 4 equals y plus 2, and then subtract 2. -2 plus or minus the square root of minus x minus 4 equals y. And then you have to determine, is it the +1 or is it the -1? Which one is the answer for the inverse? Well, this is the top half of that parabola that opens sideways. Just like this is the right part of the parabola that opens down. And so to get the bottom half here, I would need the -1. So then you change your notation. So f minus 1 of x is -2 minus the square root of minus x minus 4. And you can't see that. F minus 1 of x is -2 minus the square root of minus x minus 4. So -2 minus the square root of minus x, a lot of minuses there, minus 4. And it did not, and then I'm looking at it on the worksheet, and it does not say that we have to prove that, which is just another whole step. So we don't have to prove it. So there's number 20. And that's the end of the review worksheet. So if you have questions, make sure you come in and get help.